Good morning, Nana. Mathematical induction continuation today. Yesterday, some problems we have completed. Today, continuation. The major basic formulas also you have to learn. Yesterday, we completed the major basic formulas also. Sigma n squared, sigma n cube. Okay. Once again, we have to revise the formulas once again. Mathematical induction. Second chapter. The basic formulas once again. Sigma n means sum of the first n natural numbers, that is n into n plus 1 by 2. Sum of the first n natural numbers, that is sigma n. Sigma n means n into n plus 1 by 2. Next, sigma n square. Sigma n square nothing but sum of the squares of the first n natural numbers. So that is meaning that n into n plus 1 into 2n plus 1 by 6. N into n plus 1 into 2n plus 1 by 6. And then third one is sigma n cube, sum of the cubes of the first n natural numbers, n square into n plus 1 whole square divided by 4, which also this can be written as sigma n cube is nothing but sigma n, another form is sigma n whole square. Yesterday we have learned this is. Okay, next one, sum of the squares of the even natural numbers, sigma 2n, sigma of 2n, that is 2n form, that is sum of the even natural number, that is n square plus n, and similarly sum of the odd natural numbers, that is of the form 2n minus 1, which is learn that n square. Okay, so some problems also we have finished. Some 4 or 5 questions also. Okay. Today continuation class of the problems. Some first one is formula sigma n, sum of the squares of the first n natural numbers, that is n into n plus 1 by 2, and second one is sigma n square, n into n plus 1 into 2n plus 1 by 6, and third one is sigma n cube, that is n square into n plus 1 whole square divided by 4, which is meaning that in terms of sigma n means sigma n cube nothing but sigma n whole square. Sigma of 2n, sum of the even natural numbers, that is n square plus n, and fifth one is sigma of 2n minus 1, that is n square, sum of the odd natural numbers, that is n square. Okay, next we have learned that is another sum question, exercise 2 problems. Mathematical induction principle is principle of mathematical induction, that is principle of mathematical induction, that is equal to first case is let s of 1 be true. Second one is assume that s of k be true. And next one, if it is correct by s of 1 and s of k, then s of k plus 1 is true. By three cases, the given statement is the given statement we have treated as let s of n be the given statement. So first, whatever statement is given, we have to take as the name, that is s of n. Okay. Then check it by whether it is check it by s of 1, and second one is s of k, and third one is s of k plus 1. So these cases are true. Then the statement is true for all small n belongs to capital N. The given statement is true for all small n belongs to capital N. This is the principle of mathematical induction. That is, MI means mathematical induction. Whatever the given statement is given, let it be checked out by S of n, the statement. And first case is S of 1 be true. Second one is S of k be true. And third one is if it is the condition verified that 1 and k, then S of k plus 1 is true. This is for all n belongs to n, the case the given statement be true for all n belongs to n. Then the question number remaining continuation question. Exercise 2. Prove the following. Prove by mathematical induction. Prove by mathematical induction. First question. 1 into 2, 1 into 2 into 3, 1 into 2 into 3, 2 into 3 into 4, 3 into 4 into 5, still going on up to n terms. So the summation is goes to n into n plus 1 into n plus 2 into n plus 3 divided by 4. The question is given as 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 till going on n terms, that is equal to n into n plus 1 into n plus 2 into n plus 3 by 4. Okay, we have to prove this value by mathematical induction. Okay, so whatever the question is given, first we have to treat as solution. Let s of n be the given statement. Before that, find out the value by s of n be the given statement. First, find out by nth term first. There is no nth term, so that is the first you have to write the series. First series is what? 1, 2, 3 till going on. The series will continuation. Therefore, this is or in AP or GP. First we have to check out. So if the condition is the series in the form of AP, the common difference is same. If the ratio is same, that is GP. So first read the equation in the first terms of the values, that is 1 comma 2 comma 3 till going on are in AP. The first series in the values. So let us take the values, first values of the given statement. So common difference is same, that is first term is denoted by 1. Common difference is D2, T2 minus T1, that is 2 minus 1, which is equal to 1. Then nth term of a series is A plus n minus 1 into D. So Tn means A means 1, n minus 1 into the common difference is 1. That is 1 plus n minus 1, which is equal to n. Similarly, second part 2, 3, 4. This is second and 3 and 4. So 2, 3, 4 till going on are in, this is also in AP. So AP nothing but A equal to here 2, D equal to T2 minus T1 also 2. Therefore Tn equal to 2 plus n minus 1, which is meaning that n plus 1. In similarly, third value is 3, 4, 5. So this is also in the form of three terms are in AP. So which is meaning that A equal to 2, A equal to 3, D equal to also 4 minus 3, 1. So Tn equal to 3 plus n minus 1, which is meaning that n plus 2. Therefore, nth term of the series, nth term of S1 equal to, first term is in the form of n, second terms are in the form of n plus 1, third term are in the form of n plus 2. This is the nth term of the series. Okay, 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 till going on nth term. The series will going on. So find out first nth term, whatever the nth term of the series. So observe that the first series one, second one, third one, like this the series will goes off. So 1, 2, 3 are in common difference is same. Let it be treated as the value is the series in the form of AP. AP formula is Tn. Tn equal to A plus n minus 1 into D. So this formula can be applied here to get the form of nth term of the first series of the value of the given statement. Similarly, second series we let us see how to take. 2, 3, 4 till going on are in AP. A equal to 2, D equal to 1. Therefore, Tn equal to A plus n minus 1, that is n plus 1. Similarly, 3, 4, 5 third values 3, 4, 5 till going on the series continuation. So that is R in AP. A equal to 3, D equal to 1. Then Tn equal to A plus n minus 1 into D, which is equal to n plus 2. Therefore, the series continuation of the values nth term in the form first term having the relation is n, second series n plus 1, third values are n plus 2. Therefore, this is the nth term of the series. Okay, then go to write the S of n. Next, write down the S of n. S of n means therefore the condition given statement is in the form of S of n. 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 till going on n into n plus 1 in the place you have to write first series in the form n, second series in the form that is n plus 1, third series n plus 2, which is equal to the value is given as how much n into n plus 1 into n plus 2 into n plus 3 divided by 4. Let same thing as to how to write n into n plus 1 into n plus 2 into n plus 3 divided by 4. So this is the condition as S of n. S of n means the given statement be true. The given statement be true for all the values. So first let us take the first series S of n. So given statement nth term is not there. So first we have to find the series of the nth term in the form Tn equal to A plus n minus 1 into D. A plus n minus 1 into D. Okay. All those substitute whatever the values we have substitute, then you get the values for nth term of the form n into n plus 1 into n plus 2. AP means how will you get the AP or GP means common difference of the each term is same, that is why you have to apply AP. So common ratio is same, that is you have to apply GP. So common difference A means first term, D means T2 minus T1. Then you get the value for first values of the values in the series is as n, second series n plus 1, third series n plus 2. As per mathematical induction, case 1 nothing but basic step. Basic step we have learned, that is basic step. The process of mathematical induction is first case is basic step. Let assume that, so if let S of n 1 be true or not, we have to check out. The series is first term S of n means summation of the first term. Put n equal to 1 in the LHS. First term write as LHS and here substitute by RHS. If it is both are equal, the series is always same. So LHS means first term means put n equal to 1. So put n equal to 1 in the series. N equal to 1 means 1 into 1 plus 1 into 1 plus 2. So what is equal to 1 into 2 into 3. Similarly, RHS means substitute this value 1 into 1 plus 1 into 1 plus 2 into 1 plus 3 divided by 4. So which is meaning that 1 into 2 into 3 into 4 divided by 4. 4 cancel. Then you get 1 into 2 into 3. Therefore, both LHS and RHS equal to same. Then therefore the given series S of 1 now it is true. Why? Because both are having the same values, LHS and RHS. So first the statement is true for S of 1 and the case 2. Case 2 nothing but hypothesis step. Hypothesis step. Just assume any one of the value. Assume that, assume that S of k be true. For any value of the number, let it be k. So that also he can write. So hypothesis, then S of k is 1 into 2 into 3, 2 into 3 into 4, plus 3 into 4 into 5, till going on. In the place of n, you have to write k into k plus 1 into k plus 2, which is equal to k into k plus 1 into k plus 2 into k plus 3 divided by 4. In the place of n, you have to replace by n by k. Okay. First place, in the place of put n equal to 1. In the second step is hypothesis, that is in the place of k, n is I have to write k. Therefore, the series there is no change. Therefore, S of k is 2, not S of k plus 1. Only S of k is 2. Okay. So first whatever the value have to find nth term. This is called nth term. This is called nth term. In the place of nth term, put n equal to 1 in the LHS and RHS. If the both are equal to same, then you write LHS equal to RHS. We have simplified. So S of n is 2. In the hypothesis step is assume that S of k be true. In the place of n, you write as k. Okay. Then go to the case 3. Case 3 you have to write, that is conclusion step. That is conclusion step, nothing but assume that S of k plus 1 be true. Let it be, we have to check. That means in the series we have to split continuation, you have to write in the form of k plus 1. So therefore S of k plus 1 is nothing but 1 into 2 into 3, 2 into 3 into 4, 3 into 4 into 5, till going on. Write as first as k into k plus 1 into k plus 2, k into k plus 1 into k plus 2. The same thing as k into k plus 1 into k plus 2. Okay. Then it is equal. Plus adding term, that is both sides we have to add. That term should be write as both in terms of LHS and RHS. So that is k into k plus 1 into k plus 2 into k plus 3 divided by 4 plus adding term. We don't know adding term. Up to here total overall values are k terms. Now this term should be adding both sides. Both sides should be adding both sides by k plus 1th term. Up to here we have only k terms up to here. But just in continuation term is S of k plus 1 means next term we have to find. So that is why adding both LHS and RHS. So whatever the adding term is, we don't know. That is why first we have to keep as fill in the blank. Now take the rough part. What is the k plus 1 the term in the series? That is why first write down nth term. Nth term we have what? N into n plus 1 into n plus 2. Nth term we have n into n plus 1 into n plus 2. So in the place of n, we have to write k plus 1, k plus 1, k plus 1 plus 1, k plus 2, k plus 1 plus 2, k plus 3. So that is, this should be adding by both sides. By both sides, that is k plus 1, k plus 2, k plus 3. Here also add k plus 1, k plus 2, k plus 3. So this is the form. Up to here we have k terms. Now write down the k plus 1 term. So that should be adding on both sides. The k plus 1th term is k plus 1 into k plus 2 into k plus 3. This is the rough part. So how to get the k plus 1 term means in the place of nth term you should write as k plus 1. In the place of n write as k plus 1, that is k plus 1, k plus 1 plus 1, k plus 2, k plus 1 plus 1, k plus 2, that is k plus 3. This should be adding on both sides. So now total terms will be changed into k plus 1 terms in the series. Okay. Now simplify. So which is equal to here k into k plus 1, k plus 2, k plus 3 divided by 4 plus k plus 1, k plus 2, k plus 3 are there. So let us take the common, that is k plus 1 is common in both terms and k plus 2 is common and then k plus 3 is common. Then you write here k is the remaining and by 4 is the remaining, k by 4. Then plus is as it is. This overall term we have taken common, that is plus 1. So taking this is the product value, that is 4 LCM. So k plus 1, k plus 2, k plus 3, and then taking LCM means 4 into 1, that is k plus 4 divided by 4. So whether it is correct or not, checking by verification, whether it is correct or not, verification, that is RHS you have to substitute. RHS, what is the value is given? RHS n into n plus 1 into n plus 2 into n plus 3 by 4. So that is RHS is given that n into n plus 1 into n plus 2 into n plus 3 divided by 4. Now substitute in the verify that in the place of k plus 1, n equal to k plus 1, that is k plus 1, k plus 1 plus 1, k plus 2, k plus 1 plus 2, k plus 3, k plus 1 plus 3, k plus 4 divided by 4. In the same way, we are getting the same value. Therefore, the given statement S of k plus 1 is true by mathematical induction. By mathematical induction, it is true for all small n belongs to capital N. So this is the process of finding the mathematical induction. Mathematical induction steps. This is okay. The value how to get means k plus 1 term we adding both sides by k plus 1 term, that is nth term means whatever the nth term is given put n equal to k plus 1. Substitute this is in the both sides. Then simplify. Simplify means already you can get the RHS value. All this in terms of k plus 1. How to means verify. In the place of n write as k plus 1. Then you get the same. Both answers are should be same. Therefore in total at k plus 1 by adding that expression also in the form of k plus 1 term. Therefore this is the process is known as mathematical induction. It is true for all n belongs to n. Okay, this is the principle of mathematical induction. This is the most important question for 7 marks in the IP session. Okay, 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 to till going on nth terms, that is n into n plus 1 into n plus 2 into n plus 3 divided by 4. So 1, 2, 3 are in AP. Common difference is same. Just substitute by a plus n minus 1 into d. Then you get the value as n. In similar way, A plus A means first term, n minus 1 into D means common difference, T2 minus T1 also here 1, that is n plus 1. 3, 4, 5 are in AP, A equal to 3, D equal to 1, Tn equal to D equal to 1, then Tn equal to 3 plus n minus 1, which is n plus 2. Therefore, the nth term is n into n plus 1 into n plus 2. Now write in the place of nth term. So this is 1 into, the question is given in the form of S of n. S of n. Yes, Nana, Raven. Continue all this in the classwork only. Whatever the class we have the offline classes, I will check the notes. Okay, S of n is 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 till going on. N into n plus 1 into n plus 2, that is equal to, given as it is RHS you write. So the process of basic step is in the mathematical induction is S of 1 be true. So 1 into, in the place of n we have to write 1 into 1 plus 1 into 1 plus 2, that is 1 into 2 into 3. And the second RHS also 1 into 2 into 3. Therefore both the LHS and RHS should be same, nothing but the statement is true for S of 1 is true. Then case 2 hypothesis step. Assume that S of k be true. That is, in the place of n you have to write k. So k into k plus 1 into k plus 2 into k equal to, in the place of k write as k into k plus 1 into k plus 2 into k plus 3 by 4. So therefore S of k be true. Then assume that S of k plus 1, in the place of, up to here we have k terms, by adding both sides by k plus 1, then go to the summation is total becomes to the terms having the series is k plus 1 term, that should be adding by k plus 1. Then in the place of nth term we get the value as n plus k plus 1 the term. This should be adding by both sides. Then taking the LCM, the answer is over. By checking whether it is correct or not, do the verification for is in question in the RHS, put n equal to k plus 1. Both the terms will be equal. So then the statement is verified. So therefore, by mathematical induction, it is true for all n belongs to n. That is the question. Okay. Let's go to the second question. That is, in the same way we have exercise 2 problems. All these are same problems. 2 into 2 into 3 plus 3 into 4 plus 4 into 5 till going on nth terms, which is meaning that n into n square plus 6n plus 11 divided by 3. Same question pattern. In the previous question, 3 terms on the series we have. In this question, only 2 terms, two cases, 2 into 3, 3 into 4, 4 into 5 n terms, which is the summation is becomes 2, n into n square plus 6n plus 11 by 3. So this total summation value becomes to this. We have to prove whether it is the statement is true or not by using the mathematical, and just to only verify the statement is verified by cases. The steps are basic step, hypothesis step and conclusion step. That is the simple way. All these statements are always true, but we have to check it. Put n equal to 1 and n equal to k and then n equal to k plus 1. This is the process is known as mathematical induction. Very easiest chapter. Let whatever the statement we have, we don't know that nth term, this should be find out first. So nth term means first write as 2 in the series 2, 3, 4. So 2 comma 3 comma 4 till going on the series will be continue. That is, so are in AP. So AP means first term is A equal to 2 and common difference is 3. Then go to the Tn equal to A plus n minus 1 into D. That is, A means first term in the series. N minus 1 is 3 minus 2, that is equal to 1. So that is the series having n plus 1. So the first series 2, 3, 4 all the nth term is A plus 1, n plus 1. In the same way 3, 4, 5 till going on are in AP. Therefore, A equal to 3 here, D equal to common difference is 3, 4 minus 3, that is also 1. Then Tn equal to 3 plus n minus 1 into common difference is 1. So n plus 2. Therefore, the nth term of the series in the form n plus 1 into n plus 2. So this is the series having the nth term of the series. Now write as let given statement, let S of n be the given statement. Let S of n be the given statement, then S of n such that 2 into 3 plus 3 into 4 plus 4 into 5 till going on n plus 1 into n plus 2 which is equal to n into n square plus 6n plus 11 divided by 3. So the total expression, so this is the nth term. We already find this is called nth term of the series. How to find the nth term means? So nth term is nothing but Tn in the form of a plus n minus 1 into d. So in the form a means first term of the series and a equal to 2, d means t2 minus t1. Common difference is same, that is ap. So then you get the value is n plus 1. In the similarly 3, 4, 5 next series Nana 3, 4, 5 how many you get means in the series in the question is given. It is in AP. So it is also 3 plus n minus 1 into 1. That is n plus 2. Therefore, nth term of the series is n plus 1 into n plus 2. Okay. Next, let S of n be the given statement. Then we can write as it is 2 into 3 plus 3 into 4 plus 4 into 5 till going on n plus 1 into n plus 2 equal to n into n square plus 1 into n square plus 6n plus 11 divided by 3. By using the mathematical induction step case 1 is nothing but basic step nothing but let S of n 1 be true. Let S of 1 be true. S of 1 be true. Now check it LHS and then RHS. What are the values we have? LHS you can write. So LHS means substitute put n equal to 1 in the series. That is n equal to 1 means you can get here 1 plus 1, 1, 2, 1 plus 2 is 3. So therefore LHS you can write in the place of n plus 1 into n plus 2 substitute put n equal to 1. Then you get n2 into 3. And here RHS is given as how much? N into n square plus 6n plus 11 by 3. RHS is given n into n square plus 6n plus 11 divided by 3. Put n equal to 1, that is 1 into 1 square plus 6 into 1 plus 11 divided by 3. So which is meaning that 6 plus 17 plus 1 18, 18 by 3. 18 by 3 nothing but 6. Here also 2 into 3 means 6. Therefore LHS equal to the series in the terms of LHS and in the terms of RHS both will be equal. 6 equal to 6. Therefore the series, the statement is 2 for S of n. Now it is 2. Next case 2. Case 2 nothing but basic step goes to hypothesis. Hypothesis means let it be any number of the series. Hypothesis step, that is nothing but assume that S of k be true. Write as up to k terms in the statement. Therefore S of k such that 2 into 3. So 2 into 3 plus 3 into 4 plus 4 into 5 similarly goes to the series. In the place of n we write as k plus 1 into k plus 2 which is equal to, in the place of n we write as k square plus 6k plus 11 divided by 3. Therefore, there is no change in the expression. Now it is 2. S of k is 2. Up to basic step and hypothesis steps is very easy. Okay, first put n equal to what is the basic step? n equal to 1 we substitute in the terms of nth term 1 plus 1 and 1 plus 2. So I substitute n equal to 1. 2 into 3, 6. In the terms of RHS, n square plus 6n plus 11 by 3, that is 1 into 1 square plus 6 1 plus total value becomes to 18 by 3 6. LHS equal to RHS, then you get the value is S of n, 1 is 2. In the same way, hypothesis step, assume that S of k be true. Then S of k equal to 2 into 3 plus 3 into 4 plus 4 into 5 till going on, k plus 1 into k plus 2, which is meaning that k into k square plus 6k plus 11 divided by 3. Therefore, S of k is 2. Next, go to the case 3, conclusion step. So, assume that S of k plus 1 be true. That is S of k plus 1 such that 2 into 3 plus 3 into 4 plus 4 into 5 till going on. First write k terms, k plus 1 into k plus 2. This is k term. Then we want for k plus 1 term unknown. So let it be RHS keep as same in terms of k, right? You can 6k plus 11 divided by 3 plus k plus 1 term is unknown. So write it by unknown term by here adding both sides k plus 1 term, k plus 1 term. So this should be add and this is also added. So whatever the known means, take the rough part. Rough part put n equal to in nth term first, right? Nth term whatever we have n plus 1 into n plus 2. Now put n equal to k plus 1. Then you get the k plus 1 plus 1 k plus 2. K plus 1 plus 2 is k plus 3. So this can be added both sides k plus 1 k plus 2 into k plus 3. That is the k plus 1 term. So here adding k plus 2 into k plus 3. Okay. So that is adding both sides k plus 2 into k plus 3. Now simplify. Adding up to here we have k terms. Now next adding by both sides by k plus 1th term. That is by taking nth term means n plus 1 into n plus 2, put n equal to k plus 1. Then you get the k plus 1th term in the series. Okay, that should be adding by both sides. That is k plus 2 and k plus 3. Now simplify RHS. So here both sides we have 3 as LCM. Now simplify k cube plus 6k square plus 11k plus 3 into k into k nothing but k square plus k into 3 that is k 3k. Now multiply just a general term multiplication on a 3 to the 6. So now again simplify k cube plus 6k square plus 11k plus 3k square plus 3 plus 2 5, 5 3 ja 15, 15k plus 6 3 ja 18 divided by 3. Like term should be added. K cube plus 6 plus 3 that is 9, 9k square plus 11 plus 15 that is 26k plus 18 divided by 3. Okay, that should be adding both sides k plus 1th term. How to get means nth term put n equal to k plus 1 in the series. That should be adding and taking LCM only simplify by the RHS. Now 3 into this total term multiplication, that is again multiply by 3, total value becomes to this. This is the cubic equation. Cubic equation means solve by factorization means only it is a quadratic means you can solve by factorization, but it is cubic equation is there. So cubic equation solved by synthetic division. In the 10th class you have synthetic division. Why? Because it is a cubic equation. There is no factorize. That is means by simplify the synthetic division in the 10th class you have. So the first few letters you take the coefficients. Here not there means keep it as 1 and then remaining 9 and 26 and 18. This is the synthetic division. The process is known as synthetic division. So put here k n equal to k plus 1, that is k equal to minus 1. Why? Because k plus 1 is a factor, k plus 1 equal to 0 means k equal to minus 1. That is why put k equal to minus 1 here. Keep 0 first place in any problem. Keep in the first place we have 0 in the place. So by adding 1 plus 0 is 1. Now multiply 1 into minus 1 is minus 1. Now add 9 minus 1 is 8. 8 into minus 1, that is minus 8. 26 minus 8 means 18. 18 into minus 1, which is equal to minus 8. So the answer is 0. Therefore, by taking k equal to minus 1, put first in the place always any problem keep as 0. So here 0. Now then add 1. 1 into minus 1 as minus 1. Then here adding. Adding means 8. 8 into minus 1 you get again minus 8. 26 minus 8 is 18. 18 into minus 1 is minus 18. So minus 18 means 0. Now write as the simplified form, that is k plus 1. Keeping 0 means we got problem is over. K square, first term is k square, lesser power cubic, next 8k, and then constant. This term should be right here. K plus 1 into k square plus 8k plus 18 divided by 3. So the problem is going correct or not by checking put n equal to verification. Verification put n equal to k plus 1, that is n into here also k plus 1 whole square, simplified form. Verification do here also verification. RHS, that is n square into n square plus 6n plus 11 by 3. Put n equal to k plus 1. So that is k plus 1 into k plus 1 whole square plus 6 into k plus 1 plus 11 divided by 3. That is k plus 1, which is k square plus 2k plus 1 plus 6k plus 1 plus 11 divided by 3. Now simplified, k plus 1 into k square plus 6 plus 2 8. 8k plus 1 plus 1 plus 6 into 6. Okay. 11 plus 6 17 plus 1 18. 18 by 3. Therefore, both will be in the form of same. Therefore, S of k plus 1 is true by mathematical induction. By mathematical induction, it is true for all small n belongs to capital N. This is the process. Okay, this is synthetic division. Must learn in the 10th class you have by simplification whatever the cubic equations are there, by simplification this is the value. Okay, now verify whether it is correct or not by doing like this. In the place of n, write as RHS term you can take RHS value n into n square plus 6n plus 11 by 3. Put n equal to k plus 1. Substitute k plus 1, then simplify. Both the answers are same. So equal. Therefore, the correct answer, the statement is true for all a k plus 1. Then mathematical induction, it is true for all n belongs to n. Okay. This is the question number. We may next question. Okay. Then next write down the next question. First what we have taken nth term, and then k term we have written, k term we have written s of n, and then k plus s of k and s of k plus 1. Okay. In the place of k, in the place of n, we write n equal to k, and then go to the s of k plus 1. By adding k plus 1 on both sides, the total statement will be goes to in terms of k plus 1. by adding nth term, whatever nth term we have put n equal to k plus 1. This should be adding on both sides. Simplify. Simplify means whether it is correct or not by verification. Put n equal to k plus 1 in the RHS. Why? Because all are in the k plus 1 term. The answer should be in terms of k plus 1. That is why take the RHS n equal to k plus 1. Then you get the answer will be both are will be equal. The question is verified for s of k plus 1. This is the just verification parts. Mathematical induction. So mathematical induction it is true for all. N belongs to n. Okay. Then go to the next question. Question number 4. Only question number 3. Sorry. One squared plus one squared plus two squared plus one squared plus two squared plus three squared till going on in brackets in terms it is equal to n into n plus 1 whole square into n plus 2 divided by 12. So 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square till going on in brackets n into n plus 1 whole square into n plus 2 divided by 12. Okay, this is the question. By check it by mathematical induction. Now write the first statements. So solution, first we don't have the nth term. So let it be, nth term means you have to find. So first term is 1 square. Second term is 1 square plus 2 square. Term 3 is 1 square plus 2 square plus 3 square. In the same way, fourth term means 1 square plus 2 square plus 3 square plus 4 square. And fifth term means 1 square plus 2 square plus 3 square plus 4 square plus 5 square. Similarly, you get the nth term. Nth term means 1 square plus 2 square plus still going on right as n square, which is meaning that sigma n square. Sigma n square means what? Formula n into n plus 1 into 2n plus 1 by 6. So this is the formula for nth term of the series. This is summation of the total first n natural numbers, squares of the first n natural numbers. So now see, let given statement be. Let given statement be s of n. Therefore, s of n such that 1 squared plus 1 squared plus 2 squared plus 1 squared plus 2 squared plus 3 squared till going on in the end place you can write as n into n plus 1 into 2n plus 1 by 6, which is meaning that n into n plus 1 whole square into n plus 2 divided by 12. The total summation is given to n into n plus 1 whole square into n plus 2 divided by 12. Okay, the value is given is like this. Okay, now as per mathematical induction case 1 is nothing but basic step. Basic step is put n equal to, let n equal to 1, that is s of 1 be true. Whether it is wrong or right you have to check up. That is s of 1 be true. Put in the LHS, similarly in the terms of RHS. Both will be equal or not, which we have to check. Put n equal to 1. N equal to 1 means 1 into 1 plus 1 into 2 into 1 plus 1 by 6. That is 1 into 2 into 3 by 6. That is equal to 1. In the same way RHS, RHS you take 1 into 1 plus 1 whole square into 1 plus 2 divided by 12. That is 1 into 1 plus 1 is 2. 2 square means 4. 1 plus 2 is 3 by 12. 12 means cancel out. That is also 1. Therefore, LHS is 1. RHS is 1. LHS equal to RHS. Then we can say that S of 1 is 2. This is the process S of 1. Okay. Next, second part, S of hypothesis, the case 2. For any value let it be k. Hypothesis step. Assume that S of k be true. Therefore, S of k in the place of n you have to write only by k. 1 square plus 2 square, 1 square plus 2 square plus 3 square, till going on k into k plus 1 into 2k plus 1 divided by 6, which is equal to write as RHS in the term write as n equal to k in the place of RHS. That is k into k plus 1 whole square into k plus 2 divided by 12. Yes, k into k plus 1 whole square into k plus 2 by 12. Now, therefore, S of k is 2. Now, case 3. Conclusion step, that is assume that S of k plus 1 be true. That is S of k plus 1, which is equal to 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square till going on. Write as it is k terms 2k plus 1 divided by 6 plus adding term we don't know, that is k plus 1 we have to find. And similarly this is k into k plus 1 whole square into k plus 2 divided by 12, and here also we can add by k plus 1 term. So that is adding both sides, k plus 1th term, k plus 1th term, k plus 1th term we don't know, we have to add. That is take the rough part. How to find the k plus 1 term means nth term we have to write. In the place of nth term we put n equal to k plus 1. What is the nth term? N into n plus 1 into 2n plus 1 divided by 6. Now substitute k plus 1, k plus 1 plus 1, k plus 2, 2 into k plus 1, 2k plus 2 plus 1, that is 2k plus 3 divided by 6. Now here adding k plus 1, k plus 2 into 2k plus 3 divided by 6. Here also we can add, that is k plus 1 into k plus 2 into 2k plus 3 k plus 1 into k plus 2 into 2k plus 3 divided by 6. This should be adding both sides by k plus 1 theta. Now simplify. So that is the value. How to get means k plus 1 theta means take the rough part, that is put n equal to k plus 1 in the series. So n equal to k plus 1. Nth term is what? N into n plus 1 into 2n plus 1 by 6. Put n equal to k plus 1. Put n equal to k plus 1. Then the value is get to this has to write as both sides. Then the series, total series can be goes into k plus 1 terms. So therefore, this value is by adding by k plus 1, k plus 2, 2k plus 3 divided by 6. So now simplify. How to get means. In the both terms we have k plus 1 is common, k plus 2 is common. Now take the k plus 1 in the both terms we have common number. So k plus 1, k plus 2. Here 12 is there, here 6 is there. Then you get 6. 6 also you can get the common value divided by 6. Divided by 6. Now the remaining k into k plus 1. K plus 2 also one part is over, k plus 2 over 6 common means then you get the value here by 2 plus here k plus 1 k plus 2 is common over, then 2k plus 3 divided by, divide not necessary, by 6 already over, by 6 already here. So k into k plus 1, k into k plus 1 by 2 plus 2k plus 3. So which is meaning that k plus 1 into k plus 2 by 6, then LCM as to 2. So k square plus k plus 2 into 2k means 4k plus 6. Now simplify. Just multiply here, Nana. 2k, 2 to the 4, 4k plus 6. That is k square plus k plus 2, 4k plus 6. Now simplify. K plus 1 into k plus 2 by 6 into whatever the value we have, k square plus 5k plus 6 by 2. K square plus 5k plus 6 divided by 2. Now multiply k plus 1 into k plus 2 divided by 12. By doing the factorization, factorization means k square plus 5k plus 6. First and last terms we can multiply 5, 6 1 just 6, 6 1 just 6 and 3 2 just 6. So this is by adding middle value 5k multiplying okay. Then 3k plus 2k plus 6. Now multiply common in terms is k into k plus 3 plus 2 into k plus 3. Just doing the factorization k plus 2 into k plus 3. Now here write down k plus 2 into k plus 3 for the value for k square plus 5k plus 6. Now simplify again k plus 1 into k plus 2 whole square into k plus 3 divided by 12. Therefore, it is true or not, doing the verification. Verification nothing but taking the RHS, whatever the RHS we have, k into n into n plus 1 whole square into n plus 2 by 12. N into n plus 1 whole square into n plus 2 by 12. Put n equal to k plus 1. N equal to k plus 1 means k plus 1 plus 1, k plus 2 whole square, k plus 1 plus 2 that is k plus 3 divided by 12. So in the place of k plus 1 we write as in terms of n, that is n plus 1 whole square, n plus 2 divided by 12. Okay, therefore S of k plus 1 is true. By this is method is called by mathematical induction. By mathematical induction, it is true. It is true. It is true for all n belongs to n. That's all. This is the process is known as mathematical induction. That is, first term we have nth term in the form is sigma n square n into n plus 1 into 2n plus 1 by 6. Let the given statement be s of n. So write as in the place of nth term is like this equal to this. And check it the basic step, that is s of 1 be true. Both sides put n equal to 1 in the LHS and similarly RHS. Both the expressions are equal. Therefore, S of 1 is 2. Next, n equal to k. K into k plus 1 into k plus 2 by 6. And then equal to, in the place of n, we write as k. K into k plus 1 whole square into k plus 2 by 12. Therefore, S of k is true. In the similarly, S of k plus 1 is true. That is 1 square plus 2 square plus 3 square 1 square plus 2 square plus 3 square is going to like this. Okay. So that is k into k plus 1 into k plus 2 into k plus 2k plus 1 by 6. K into k plus 1 whole square into k plus 2 by 12. Adding both sides by k plus 1 term. This term should be how to get means take rough part nth term in the series. Nth term we have, that is nth term is n into n plus 1 into 2n plus 1 by 6. Put n equal to k plus 1. N equal to k plus 1 nothing but in the place of n write as k plus 1, k plus 2, 2k plus 3 by 6. Adding both sides by this value and then simplify both the terms having k plus 1 and k plus 2 are common in the both terms. Take the common. So k into the remaining term is k into k plus 1 by 2 and here k plus 1 k plus 2 by 6 common out, then 2k plus the remaining. And in the bracket in the place also take the common as 2 k square plus k plus 2k, 2 into here multiply 4k plus 6 and then k square plus 5k plus 6 by 2. So 6 2 are 12 right here. K square plus 5k plus 6 by doing the factorization k plus 2 into k plus 3. Now multiply. Now multiply means k plus 1 into k plus 2 whole square into k plus 3 divided by 12. Therefore it is 2 in the place of in terms of k plus 1 as n. So n plus 1 whole square n plus 2, that is by 12. So it is verified. Therefore, if it is substituting n plus k plus 1 term, the total series goes to same only in terms of k plus 1. So that is why the given statement is true for all k plus 1. So that is the question. By using the mathematical induction. By using the mathematical induction, it is true for all n belongs to n. Okay. Then go to the next one. Next question. Question number 4. Most important question. This is 1 cube by 1 plus 1 cube plus 2 cube by 1 plus 3 plus 1 cube plus 2 cube plus 3 cube by 1 plus 3 plus 5, then simplified up to n terms, which is meaning that n by 24 into 2n squared plus 9n plus 13. 2n squared plus 9n plus 13. Okay, the question is most important. So in the IP session, they will give so many times as repeated. Okay, that is 1 cube by 1 plus 1 cube plus 2 cube by 1 plus 3, 1 cube plus 2 cube plus 3 cube by 1 plus 3 plus 5. That is total going to n terms, which is equal to n by 24 into 2n square plus 9n plus 13. So that is first whatever the statement is given, first find out the nth term. So there is no nth term in the series. So here separately we have to find. So nth term means first numerator you can take. Numerator is 1 cube first term and then second term is 1 cube plus 2 cube. Third term is 1 cube plus 2 cube plus 3 cube is given. Similarly nth term means goes to 1 cube plus 2 cube plus 3 cube till going on as how many terms means n terms means n cube, which is meaning that sigma n cube, that is n square into n plus 1 whole square by 4. In the same way, denominator. Denominator is in the form of 1 and 3, 1, 3, 5 till going on. Series will be going on in terms, which is meaning that or in AP. 135 sigma to an or else you can take 135 or in all the numbers are in the form of odd numbers, that is sigma of 2n minus 1, which is meaning that n square we already find. So therefore Odd numbers nana 1, 3, 5, 1, like that going on. Summation of the odd numbers, sigma of 2n minus 1. First formula we learn sigma of 2n minus 1. Sigma of 2n minus 1 is n square. Sigma of 2n is n square plus n. Okay. So that is why we have written as n square directly. That is sigma of odd numbers n square. Then nth term of the series numerator by denominator, which is meaning that n square into n plus 1 whole square by 4 divided by n square, which is n square cancel, n plus 1 whole square divided by 4. This is called nth term of the series. Therefore, let S of n be the given statement. Let S of n be the given statement. Therefore, S of n such that 1 cube by 1 plus 1 cube plus 2 cube by 1 plus 3 plus 1 cube plus 2 cube plus 3 cube by 1 plus 3 plus 5 till going on. In the place of nth term, we write as n plus 1 whole square by 4, which is equal to n by 24 into 2n square plus 9n plus 30. As it is mathematical index 10 steps we have to follow. First, whatever the given statement is given, find out the nth term of the series. Then go to the basic step. Basic step nothing but let case 1. Case 1. That is basic step. Let assume that S of 1 be true. Put LHS and RHS separately contained. In LHS, 1 plus 1 whole square by 4. Which is meaning that 1 plus 1 means 2 square. 2 square by 4 means 4 by 4, which is 1. Here 1 by 24 into 2 plus 9 plus 13. So 24 by 4 before, which is also same. Therefore LHS equal to RHS. Then that implies we can say that S of 1 is 2. Now not B. Now it is verified, then it is S of 1 be true. Both the cases have the answers is 1. In the same way, case 2. Case 2. That is hypothesis step. Let assume that S of k be true. Therefore, S of k is such that 1 cube by 1 plus 1 cube plus 2 cube by 1 plus 3 plus 1 cube plus 2 cube plus 3 cube by 1 plus 3 plus 5 till in the place of n we write as k plus 1 whole square by 4, which is equal to k by 24 into 2k square plus 9k plus 13. 2k square plus 9k plus 13. Okay. Therefore, S of k is 2. Now next case 3, last one. Case 3 nothing but final conclusion step. Assume that S of k plus 1 be true. Therefore, S of k plus 1 is such that 1 cube by 1 plus 1 cube plus 2 cube by 1 plus 3 plus 1 cube plus 2 cube plus 3 cube by 1 plus 3 plus 5 till going on k plus 1 whole square by 4. In the place you can adding the nth term. Nth term means in the place of 1 you can write k plus 1 plus 1, k plus 2 whole square by 4, which is nothing but k by 24 into 2k square plus 9k plus 13 plus adding both sides k plus 1, whichever whatever the value means, this is the value. How to get means adding k plus 1 term on both sides, that is the term is this. Adding both sides means n equal to nth term. Nth term means n plus 1 whole square by 4 is the nth term. In the place of n, you can write as k plus 1. So k plus 1 plus 1, that is k plus 2 whole square by 4. So that much only I added. This is the rough part. So nth term you can take, in the place of nth term, you can substitute by k plus 1, then you get this value. This is adding both sides by k plus 1th term. K plus 1th term means how to get means put n equal to k plus 1 in the nth term. Nth term means n plus 1 whole square by 4. Put n equal to k plus 1. So k plus 1 plus 1, k plus 2 whole square by 4. Now simplify by the RHS. Simplify by the RHS means taking LCM, that is 24 most LCM. So 2k cube plus 9k square plus 13k plus 4. Here 4 is there, here 24 is nothing but 6 times. 6 times of k plus 2 whole square. K square plus 4 plus 4k. A plus b whole square form. Now simplify 2k cube plus 9k square plus 13k plus 6k square plus 6 4 ja 24 plus 24k divided by 24. Now again simplify 2k cube plus how much 9 plus 6 15k square 2k cube plus 15k square plus 13 24 plus 13, that is 37. 4 plus 3 7 37. 37k plus 24 divided by 24. Yes, whether it is correct or not. 2k cube plus 15k square plus 37k plus 24 divided by 24. Here also you got cubic equation. Cubic equation means solve by synthetic division. Solve by synthetic division. So write as coefficients 2, 15, 37, 24. So now put in the place of 0. Write k plus 1 equal to 0 means k equal to minus 1. Minus 2, 13, minus 13, 24, minus 24. There will be goes off. Therefore, the factors are k plus 1 into 2k square plus 13k plus 24. Now here write as k plus 1 into 2k square plus 13k plus 24 divided by 24. So therefore, the problem is continuation. Is are correct or not by doing the verification. Verification means nth term, last RHS. RHS is what? RHS k into n by 24 into n by 24 into 2k square 2n square 2n square plus 9n plus 13. Put n equal to k plus 1. So k plus 1 by 24, 2 into k plus 1 whole square, 9 into k plus 1 plus 13. That is k plus 1 by 24 into 2 times of k square plus 2k plus 1 plus 9k plus 9 plus 13. So k plus 1 by 24 into 2k square plus 4k plus 2 plus 9k plus 9 plus 13, which is meaning that 2k square plus 9k plus 4k 13k plus 13 plus 2 13 plus 2 plus 9 24 into terms of k plus 1 by 24. Therefore, this part and this part is same. Therefore, S of k plus 1 is true. By mathematical induction, it is true for all n belongs to capital N. This is the part. So value is goes to mathematical induction. This is the rough part, whether verification. whether verification, whether it is correct or not by doing the verification. Okay, by doing the verification. This is in the terms of k 2n squared plus 9n plus 13. Put n equal to k plus 1. K plus 1 by 24. 2 into k plus 1 whole square. 9 into k plus 1 plus 13. Simplify, then you get the both the answers will be same. Therefore, s of k plus 1 is 2. By mathematical induction, it is 2 for all n belongs to n. Okay, this problem's continuation tomorrow I'll explain, Anna. Okay, revise the notes and formulas. All the notes I will be checking in the offline session. Okay, whenever we college will start, I will check the notes. Okay, Nana, right? Thank you. Revise all this.